Guys, these are your guided notes for Unit 6, Properties of Circles. It's a whole unit talking about everything you could ever want to know about circles. We're starting out with just some basics and a lot of vocab, talking about something called arcs. This is all in your workbook, so you need to have your workbook out. It needs to be open to page 75. I will be checking these guided notes tomorrow, so make sure you're doing them. If you don't have your workbook, I'll have a couple extra pages printed off and handed to the sub. So if you need one, you should be either looking at your Chromebook or looking at a friend's Chromebook, but you should be writing this down no matter what if you want credit for today. First vocab word is a circle. We're talking about circles. You need to know what they are. You've drawn them before. You've seen them drawn before. It's officially the set of all points that are equidistant from the center. So they're all the same distance away from the center, so it doesn't look lumpy or anything like that. Then we have a radius. This is your segment that has one endpoint at the center and one endpoint on the circle. So if it starts at the center, goes to the edge, that's a radius. If you have two circles with the exact same radius, those circles are congruent. So unlike with triangles where you had to have all the sides congruent, all the angles congruent, with a circle you just have to have same radius, done, same circle. Doesn't come up a lot, but I still needed to tell you. Next, we've used before is a diameter. It's your segment that joins the center of your circle, goes through the center of your circle, and has both endpoints on the circle. So you know what it looks like. It goes all the way across. It's two radii glued together in a straight line, but officially goes through the center, has both endpoints on the circle. There is a vocab word that you'll need for the IXL today that I forgot to put in the workbook. If you have both endpoints on the edge, like a diameter, but you don't go through the center, so if I had a line kind of over here, that would be called a chord, C-H-O-R-D, a chord. It will come up a lot this chapter. We're not going to use it today, which is why it's not in the notes, but it will show up on an IXL when it's just practicing vocab. By drawing in all these radii, though, we have something called a central angle. It's an angle whose vertex is at the center, remembering that vertex first semester meant corner of your angle. So like this angle here would be considered a central angle because the corner of the angle is at the center of the circle. I've also included another vocab word you'll need from the IXL. Put in here that this is a sector. If you had this entire piece of pie or piece of pizza here, that would be a sector. So it's not just the edge around the outside of a circle. If we start talking about the filled in inside part, that's a sector. It'll come up this unit. It'll come up on the IXL today. Just make sure you know what it is. Next vocab word is an arc. Arc meaning part of a circle. So if you were drawing a circle but you stopped before you got all the way around, you've drawn an arc. So it's just part of the outside of the circle. If you were drawing a circle and you only drew half of it, half of a circle is considered a semicircle. And since a full circle is 360, half of a circle, a semicircle, is 180 degrees. Then we have something that's called a minor arc. It's where you were drawing the circle, you stopped drawing, but it's smaller than a semicircle. So you were drawing the outside of your circle and you only drew part of it. The really important thing today is that the measure of this minor arc is the same as the measure of the corresponding central angle. So if I know that this angle over here is 100, then this arc over here is 100 because the whole circle is 360, just like all these angles are 360 as well. A major arc is greater than a semicircle. So you're drawing your circle, you didn't go all the way around, but you went more than halfway. So if it's bigger than a semicircle, its measure will be 360 minus the measure of its related minor arc. We'll do examples of this in a second. Congruent arcs will have the same measure and either have to be in the same circle or a congruent circle. So if we happen to find them with the same number, we're going to say that they are congruent. Again, doesn't come up a lot, but something we need to know. So some examples of these arcs. Minor arcs being less than half of the circle. For example, I could say arc CB because this curved piece is less than half the circle. It's less than a semicircle. I could also have said arc DA, less than a semicircle. Less than half. You'll also notice I'm using two letters for a minor arc. That's extremely important. And I also put a little curved arc mark over the top. Major arcs will still have that curved mark, but they have to use three letters. Because, for example, if I wanted to still start with C and end at B, but I needed it to be a major arc. I don't want to go the short route here. I want to go from C, pass through D, and then stop at B. Yes, I passed through A as well, but you still only use 3 letters. So don't call this C, D, A, B. We only use 3 letters, so I just chose D. C, D, B is the name of that major arc. Starting at C, heading toward D, and not stopping drawing the circle until I hit B. That would be a major arc. Arc DAB would also be a major arc. Starting at D, heading toward A, stopping at B. So 3 letters, more than a semicircle. When we go to name a semicircle, you will still use 3 letters. The first and the last letter will be where you start and stop the semicircle, but you have to put a middle letter in to say which way you went, essentially. So for example, if I wanted to name this kind of rightish semicircle, I want to start at C. I'm going to say I'm heading on the right toward B, and I'm stopping at A. Half of my circle, semicircle on the right. But there's another semicircle. It also starts at C and ends at A, but this one passes through D. So I would name it arc C, D, A. Remember, at any point in these notes, if you need to pause it and write stuff down, feel free to do so. So then we've got a picture at the bottom of page 75. We've got this circle. We have a bunch of letters on it. We're supposed to name things. And it actually starts out with angles. So remember, when you name angles, you name 3 letters, and your middle letter has to be the letter that's your vertex, the corner. So when we name part A, B, C, D, those are all asking angles. O better be the second letter we say every time. So if we want an acute one, acute means less than 90 degrees. Small is usually how we think about it. There's several in the picture, but one is angle AOD. So this is smaller than a 90-degree angle. It has O as my vertex, O is my corner, and I'm just saying AOD. There's more than just AOD, but that's the one I chose. An obtuse central angle, meaning I need this angle to be more than 90 degrees. The one I chose is angle DOE. This angle is more than 90, but less than 180. Has O at the vertex. Straight angles, we said first semester, equaled 180 degrees exactly. There are 2 in this picture. The one that I named is angle AOE. So a straight line, but it technically is a straight angle. We do have congruent angles in this picture. If you remember, anytime we have lines that intersect in this X shape, we always had vertical angles. So I do have 2 sets of vertical angles. The ones that I wrote down would be the acute vertical angles. Angle AOD over here, and angle COE on the other side. They're across from each other in the X shape, therefore they are congruent, they are vertical. The rest of the question want arcs. So the first one says minor arcs. So I need to name 2 letters, and they have to be congruent. So I said the important thing on the other slide was that the measure of the arc is equal to the measure of the angle. So if I know angle AOD is the same as angle COE, I know this little bitty arc here, AD, is the same as the one across from it, arc CE. So I could say arc AD is congruent to arc CE. They are congruent arcs. They are minor arcs. If I wanted 2 minor arcs that are not congruent, I just need to make sure that they don't pair up with vertical angles. So I'm still going to use AD, and a minor arc that's not congruent to it would be AC. So yes, AC pairs with an obtuse angle, but remember, minor arc just meant less than 180, and AC is less than a semicircle, less than half the circle. So AD and AC are minor arcs. They are not the same, though. There are 2 semicircles in this, actually there are 4 semicircles in this picture. I only wrote down 2 of them. One of them would be arc ACE, so starting at A, heading towards C, and ending at E. Semicircles have to use 3 letters. I could have said ADE and used that little bottom arc there, but I didn't. I also listed arc DAC, so starting at D, heading toward A, ending at C. I could have also used the one on the other side of it, DEC. There are 4 semicircles in this picture, and I only wrote down 2. Then it asks to name major arcs that contain the point A. Major arcs have to use 3 letters. They have to be larger than a semicircle. There are more than 2 in this picture. I just only named 2. So I used the one that started at D, hit point A, and then kept going. I can't stop at C because that would be a semicircle, so I said stop at E. So arc DAE, 3 letters, saying where I started, where I stopped, and what letter I passed through on the way. I ignored the fact that I passed through C because I can. The other arc I used was arc AEC. So maybe I started A, I headed over toward E, and then I stopped at C. More than a semicircle, named 3 letters. Once you get the hang of naming all these things, I just realized yours asks for diameter and radius and mine doesn't. Sorry about that. The diameter in this circle is segment, DC. When you name a segment, you name 2 letters. I'm ignoring O being in the middle. Starting at D, heading towards C, the diameter is DC. The radius in the circle, there's several I could have named, but it has to use point O and go to the edge, so maybe OA is a radius on your circle, or OE, or OC, or OD. There's a lot, but I don't have it on my slide, sorry. So anyway, once you get good at naming them, you can actually use it using this property about adjacent arcs. Adjacent, remember, means next to each other. If you have 2 arcs that are next to each other, they just have one point in common, they don't overlap, and you can add, that's the important thing here, you can add those measures just like you add angle measures. So if I knew YM is next to MW, I could just add those 2 arc measures together and I know the whole arc's measure. That's called the arc addition postulate. We've had segment addition postulate, we've had angle addition postulate. Now we're just doing the exact same thing but for arcs. And again, the measure of the arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. We just said that. So if they're next to each other, you can add them. So I need to go back. So anyway, once you have all the names down, you can use them to start finding angle measures. But I never recommend that you just start filling out a picture like this and answering the questions. I always recommend you fill out your picture first. So what I want to point out is I have an arc and I have an angle. But we said the important thing was if you know the measure of an arc, it pairs with the measure of the angle that's at the center. So I know this angle would be 40 degrees because the arc that it intercepts is also 40 degrees. Which means if this is a 56 degree angle, the arc that it intercepts is also 56 degrees. So we can fill out part of it that way. Next, I want to move kind of above that over here. There are 2 ways you could do this. One of it thinking, hey look, I have a straight angle. Straight angles equal 180 degrees. So if I add up the 2 angles I already know, making 96 degrees, and I have to make 180, I'm going to do 180 minus 96, which gets me 84. And like we just said, if we know the central angle, we know the arc that intercepts. That's also 84 degrees. Likewise, we could do the same thing on the other side. We could say, hey look, straight angle YCW is a straight angle. So if this has to be 180 degrees, I'm going to take 180 minus 84. Those are both 96 degrees. We could do another straight angle, but don't forget vertical angles exist. If this guy is 84, that guy is 84. And if the angle is 84, the arc's 84. So doing all that work, you get the whole picture filled out. Answering the questions is so much easier when you have that done. So the first thing is arc XY. It's a minor arc because there are only 2 letters. Starting at X, heading toward Y. Those are 2 adjacent arcs that we are allowed to add together. So 56 plus 40 is 96 degrees. Next is arc DXM. It's a major arc or possibly a semicircle because there are 3 letters. So if I go find it, D, head toward X, end at M. You'll notice if you're tracing that, you have to go through 3 adjacent arcs, which is fine. Just add those 3 together. So 96 plus 84 plus 56 is 236 degrees. Next is arc MWX. Again, it's either a major arc or a semicircle. Let's go find it. Starting at M, heading toward W, and ending at X. So when I am actually adding those adjacent arcs, that was one of the semicircles we had used earlier. So it will be 180 degrees since it's half of our circle. Next, another major or semicircle, YMX. So Y toward M, end at X. You could add 84 plus 96 plus 84. That'll get you that arc. Or you could do it another way. You could say, hey, I've got this whole circle and I want all of it except I don't want the 40 and the 56. So you could also do 360 minus 40 and 56, or you could do 84 plus 96 plus 84. Whatever way makes